First, I would like to appreciate the symposium committee to give us this great opportunity to present our work. I'm Huifeng Qian, the Product Research Center in Olin Epoxy R&D. So this work, we work with Wendell from the AIT Composite for the epoxy-based FRP Rebar. So the title of today's presentation is a novel VOC-Free epoxy system for high modulus glass fiber reinforced polymer Rebar. Here is an outline for my today's presentation. So first I will have a quick introduction for Olin and why epoxy for FRP Rebar. And then I will discuss the testing method and the specification related to the FRP Rebar. And after that, I will mainly discuss the LITESTONE epoxy system for the FRP Rebar. I will present some data regarding the testing result. Okay, very short introduction for the Olin. So Olin is a company founded in 1892. It has a long history in the chemical industry. Olin has been listed in the New York Stock Exchange for over 100 years. It has over 7,000 employees globally in 3 continents. So our LITESTONE is the brand name for the epoxy system for using the Olin epoxy. We provide the reliability and the performance and skill for our customer over the applications such as infusion, film winding, pultrusion, etc. Sorry, boss. Correction. Okay, so here I show the Olin's epoxy global manufacturer footprint. We have 3 large epoxy resin manufacturing sites in the Freeport, Texas, Stade, Germany, and Perugia, Sao Paulo, Brazil. And I have the system house in Rebar, Georgia, Ramos, Modulus, this in Europe, and also we can supply our epoxy system to the customer all over the world. So why epoxy for the FRP Rebar? In the last 2 years, we promote epoxy system for the FRP Rebar applications. The biggest advantage of the epoxy for the FRP Rebar production is the styrene or VOC-Free feature. Epoxy system requires the styrene and the resin dilute to provide the better working environment. And so the epoxy has a broad choice for the monomer and the curing agent. So it can provide the versatile formulation. Without the low boiling point resin dilute, the epoxy system can be cured at much higher temperature compared with other thermoset resins like 1S or polyester. By tuning the system, it can be also achieve the fast reactivity, so epoxy can achieve high throughput production, especially for the Rebar process. So epoxy is also well known for as a protect coating for the metal. So this corrosion resistant feature fits well with the FRP Rebar applications. Epoxy also the resin matrix choice for the windmill blade, which is due to its high fatigue performance. And epoxy also very compatible with different fiber systems, like the flat fiber or fiber or carbon fiber. So it is a very versatile system. Typically, epoxy can offer higher TG than the 1S or unsaturated polyester. It is good for many testing. For example, the serious corrosion resistant ASTM D7757, which is tested at 60 degrees C. The high TG will help the testing. And so epoxy has is well available all over the world. So it provides the supply chain reliability for the industry. The VOCs from the FRP rebar manufacture process. Here, I draw in for the typical rebar manufacture process. So basically, the fiber will go through the resin bath. The fiber will impregnate the resin, and then go through the preformer guiders to remove the excess resin, and then cure either in the oven or like the dye. That's the process. And it will form the solid rod, the rebar shape, and then it will cut to the design length based on the requirement. For the one ester or potential polyester, because we typically use styrene as a resin guide. Styrene has some EHS concerns. It has low flash point, so it's flammable. It has low boiling point and high vapor pressure. Styrene also has a very strong odor. Also, styrene is considered as carcinogenic suspect to humans by the International Association of Research. So the VOC is mainly from the oven bath and the curing process. For epoxy system, because we don't use styrene, so we don't have this kind of VOC issues. We promote the LITESTONE system for the FRP rebar. It offers the VOC-Free, fast reactivity, and also the performance of the bag can meet or exceed the performance target, like ASTM D7957 or V5. Here I show some images for the GFRP rebar based on our system, and also I will show a video. Hopefully it works. For the production of the basalt fiber BFRP rebar with our LITESTONE system. So you will see the production is very smooth, the surface quality is good, and it also offers a decent line speed. So here I show the basic resin properties for the LITESTONE system. The LITESTONE 3200E and 2131H US is our workhorse for the FRP rebar applications. So the mixing with solid is around 500 centipoints. We consider this mixing with solid is a good range for the fast fiber impregnation. When the viscosity is too high, the impregnation is low. It takes time to wet the fiber. But when the viscosity is too low, it is like a water, and the fiber cannot just take enough resin. So when cured, you have a lot of dry fiber. So this viscosity is in the right range. And so the gel time is over 24 hours. So it didn't gel fast. We also mentioned the viscosity increase by monitoring the viscosity, mixing with viscosity at the room temperature. Overall, the pore life should be more than 6 hours. So it is more than enough for the rebar process. The gel time and 140C is about 3 minutes, and TG is 125C. Here I also show the viscosity versus temperature profile. Basically, initially before 80 degrees C, the temperature will, with the temperature increase, the viscosity will drop, which is good for the fiber impregnation. And then once you reach like 90 to 100 C, the temperature, the viscosity will increase very fast, like the fast reactivity. So this system basically shows the design balance of the fast reactivity and the long pore life. After that, I will discuss some testing results for the epoxy-based GFRP rebar, but I first want to have a very short overview for the testing method. So the tensile properties is a key characteristic for the epoxy rebar. So like tensile strength, tensile modules. And the alkaline resistance testing is very critical for the Rebar, because Rebar is the feature for the corrosion-free. This test is conducted at 60 to 90 days in the alkaline solutions. And the transport shear strength testing reflects the interaction between the resin and the fiber. And so the bond strength of the Rebar to the concrete by power test reflects the interaction between the Rebar and the concrete. The glass transition temperature can be measured by the DSC or DMTA. The requirement is over 100 C for the DSC testing method. And the degree of cure can be also measured by the DSC. Here we show some imagery for this testing, like tensile shear, concrete bond strength, and alkaline resistance testing. Okay, regarding the material specification, so for the ASTM there are two material specifications. One is 7957. This is considered the generation 1 FRP Rebar standard specification. The tensile modulus requirement is 44.8. It includes one ester and the glass fiber as the material choice. So the ASTM D8505 published last year, April last year. So it set a high standard for the FRP Rebar, considered the generation 2 or the high performance FRP Rebar standard specification. The tensile modulus requirement is about 60 gigapascal, and other properties like the transverse shear or pull out, like the bond strength, also higher. So it includes both epoxy 1 ester and the resin metric, and also glass and the fiber. Here we show the data for the number 3 epoxy-based GFRP bar. So the tensile modulus is about 70 gigapascal, and the tensile strength is 1,000. And the degree of cure is near 100%. It reflects the high fast reactivity of the system. And the alkaline resistance test showed the tensile strength retention is well above the 80%, which is the requirement. Overall, the LITESTONE system-based GFRP Rebar meet or exceed the current ASTM D7957 or ASTM D85. So similar for the number 4 bar, the tensile strength is about 1,000 megapascal. Here the data is about 1,200. And the tensile modulus is also about 70 gigapascal. The degree of cure is near 100%, TG is 110. So it meets all the ASTM 7957 and the ASTM D85 requirements. Here show the number 5 bar. So similar, like tensile strength is about 1,000 megapascal. Modulus is about 70. And here, for the tensile mean tensile force is 233, but the deviation is a little bit bigger. So because the guaranteed tensile force is slightly below the requirement for the guaranteed tensile force. This data is generated before the publishing of the we believe when some of the testing the deviation of different parts is guaranteed tensile force requirement. Okay, so I think here is a short summary. So we report a novel VOC-free epoxy system for the thermal setting resin matrix for GFRP Rebar. So 3 bars, 3, 4, and 5 was successfully produced in the industrial scale, and a few thousand kilometers, and tested by the testing lab. So this GFRP Rebar shows the average tensile modulus about 70 gigapascal and tensile strength about 1,000 megapascal. The bar is also tested by the accelerated testing for the corrosion resistance. at 90 days immersion in alkaline condition at 60 degrees C. So the tensile strength maintain over 80% retention post immersion in the alkaline